Hello everyone. Today I'm going to present our work on improving testing by mimicking user behavior. Before starting my talk, I would like everyone to take a moment to think of your activities in a typical day. If I'm not wrong, software is involved in most of your daily activities around the clock, no matter whether it's personal or professional. So software is everywhere in our daily life. But unfortunately, so are bugs. To reduce the number of bugs in the software, in-house testing is performed, and is typically performed manually. But manual testing may not be representative of field executions, because developers or testers may make inaccurate assumptions on how the software will be used. In addition, testers often have to compromise on the thoroughness of their tests due to time and cost considerations. Even with the help of automated testing, such as random testing, symbolic execution-based techniques, search-based techniques, and search-based techniques, there's still a gap between test and field executions, because these techniques do not leverage field execution information. So, to bridge the gap between field and test executions, we represent Replica, a test generation technique that mimics field user behavior in order to improve in-house testing. And here is how it works. The execution incremental takes the input application and produces an instrumented executable. The executable is then tested in-house and deployed, which will produce execution traces for both test and field executions. The execution processor then compares these traces and marks field traces that contain behaviors that are not covered by tests. Finally, the execution mimicker uses these marked field traces to generate inputs that can mimic those field executions. The execution traces we collect are method call sequences, and the model we use in execution processor for comparing and representing behavior differences is K-tail environments, which is a model indicating an immediately followed by relationship of sequential events up to length k. And finally, the test generation technique we use in execution mimic is an incremental guided symbolic execution. The basic idea of incremental guided symbolic execution is to guide symbolic execution towards specific program points, which we call targets. And the input to the algorithm include a program itself, a marked field trace, and a user-defined timeout. So consider this execution trace here. These dots represent method calls, and they happen sequentially in an observed field execution. These red dots are method calls that are involved in untested behavior. So the goal for us is to cover these red dots. So how do we do that? In a high level, it works as follows. First, it attempts to target the first method call that's marked in the trace. And then if it reaches it successfully, it will try to reach next marked target. However, if a target cannot be reached within a given time limit, we would add an intermediate point to reach before it continues to reach its real target. And this process continues until all the red dots are covered. So the benefit of this incremental guided symbolic execution is that it has relaxed constraints, making it easier for the solver to solve, and it also mitigates the path explosion problem, which is one of the bottlenecks of traditional symbolic execution. To evaluate the effectiveness of Replica, we used 4 benchmarks: TSL generator, grep, set, and gzip. For each of the benchmarks, we collected execution traces for in-house tests and field executions, and then identified traces that contain untested behavior. For these identified field traces, we first filtered them to remove redundant untested behavior. And then we performed test generation to mimic selected traces using both the baseline technique CLE and our technique Replica. Finally, we performed invariant inference and mutation analysis to generate further generated inputs, and the invariants and mutants are the metrics we use to evaluate the effectiveness. This table shows the result. So in terms of the invariants, the input generated by Replica covered 11.9 times more untested behaviors than those generated by CLE. And in terms of the faults or mutants, the input generated by Replica detected 5.15 times more faults than those generated by CLE. So these results show that Replica can generate test inputs that exercise more untested behavior and detect more faults than those generated by the baseline technique CLE. So to conclude my talk, we represented Replica, the technique that can mitigate the differences between field and test executions. To do that, Replica represents the differences of field and test executions as K-tail invariants, and it uses an incremental guided symbolic execution to generate inputs. And the generated input by Replica can mimic user behavior of field executions, and also reveal a large percentage of the mutants that are revealed by field executions but not by in-house tests. Also, our evaluation shows that Replica outperforms the state-of-art symbolic execution engine CLE. And this is end of my talk.